But if you would consent, then we can post this afterwards. Okay. Hi, Luis.
Hello.
Okay.
Hello.
Yeah, I can see everybody.
You always have the best microphone.
Who do we?
Me?
Yeah, you sound like you're in a radio booth.
I'm gonna start broadcasting then.
Okay. Well, so guys, from our side, we have one more guy, Gadler, who's going to join us. I'm not sure where he is at the moment. And anybody else, I don't know if we should just get started and allow people to sort of butt in. What do you think? Yeah.
Yeah, that sounds good to me. It's recorded anyway, so they can come back to what they missed.
Right, exactly. Okay, well, I'm just going to go through a little agenda, which you helped me with, Daniel. So, you know, this is really an open discussion, which means we're listening as well as talking. So, you know, anybody can jump in at any moment and offer anything. I think that's the whole point of this call. And of course, this is the first one we've ever done. So again, maybe the agenda is a bit, you know, maybe we can improve it. So also afterwards, maybe in the chat, anybody can suggest items we didn't think of or things that maybe we shouldn't have done the way we did it. So I think that's the main thing, is this is participatory. Okay, so I'm going to start. I'm just going to start, but please jump in if you need to, anybody, especially. Let me just start by introducing the Grillo team here. So Luis, seismologist, if you want to say anything, Luis.
Hello, not just welcome everybody officially.
Hey.
Carlos joined now.
And Carlo, do you want to say hello, Carlo?
Hi, can you hear me?
Yeah, we can hear you.
One sec.
Okay, so Carlo, for those who don't know, has been with Grillo for about 4 or 5 years, and he's been an advisor for the last year or so. And Carlo is a sort of CTO as well in another role, and he's, you know, been very much guiding us on different technologies in the past. Do you want to say anything else, Carlo?
Well, you say it perfectly. I've been with Grillo, with Andy since the beginning. Even I was on TV representing Grillo one time, so I'm well aware of the developments, what we're working on, and been also checking the Slack, but I haven't been so active there, but I'm reading it, and here I am. Anything I can help, love to do it.
Great. And Diego is our internationally famed seismologist from Portland. Do you want to say anything, Diego?
Sure. Thanks for calling me internationally famed. So yeah, I've been working with Grillo since I think like 2017, right after 2 very devastating earthquakes in Mexico. So I'm a seismologist, and I'm happy to help anybody, whoever has any seismology questions. I guess the only thing I would add is for everybody to be proud of themselves, because what you are doing is something very, very, very different. There is such a thing as a mainstream of earthquake early warning, and you guys are very far away from it, and that's a good thing. So if I can help in any way, please don't hesitate to ask.
Great. I was going to say, you know, we don't have a huge group here, but I don't know if we have time to go around everybody. Unless anybody has something pressing to say, I was just going to get started. I don't know if anybody. Okay, I'm just going to get started. So I'm going to start with what is OpenEEW. And I think a good place to start here is Grillo, because they're 2 different things. So the team you've just met are the people who've helped develop the technology up to a point. And then what we had to do with the help of Daniel and John and other people on the call from IBM is sort of distill the core components into something which people can use, can sort of, like, you know, run away with and help us develop. Because there's a lot of things that we did in Grillo which didn't make sense to add to OpenEEW. There was a lot of, you know, just real sort of nuts and bolts in terms of automation and stuff, which were very specific to our users. So I think we've done a reasonably okay job there. And OpenEEW, as you guys now know, as of last week, which is really why we have many of you here, and it's why we have a lot of discussions now, became a project of the Linux Foundation. And the background there is that IBM have a relationship with the Linux Foundation and helped us with the introduction And so now it's hosted there, which means to say it's not even really our project anymore. We now are part of the committee of this project, and anybody here could, eventually also join us on the committee, given enough contributions. It really is an open platform now. It's not a Grillo project anymore, although we are very invested in this. So that's OpenEEW. I don't think I need to say too much about the technology. I mean, at this point, except to say that there are, on the website, you guys, I can see all of your names. I know everybody here. I'm not sure I've spoken to Ludwig there in the past, but we have these sort of three components, which are the sensors, the hardware, which I've shown on a number of different images, and then we have the detection stuff, which John went over very well yesterday in terms of how we detect earthquakes, and there are many different ways and many new opportunities to still explore, and then how people get the alerts. So I think that's the first point. Introduction of new folks. I'm not sure, Daniel, what you meant by this. We have sort of a good team of people here. We have, the seismologists, we have developers, people from different countries. So I would just encourage everybody here to sort of be open to sort of, to engage new people on the channel, because I think part of the strength of what we're doing is partnerships, and I mean this because it's quite complicated what we're doing. There are people working on the front end stuff, and there are people working on the sensors and the back end, and we need to tie them together. So when someone on, say, we have a channel now which is networks, wants to create something in Chile, we have actually some guys who want to do it in Chile. If you guys have seen, they might need to hook up with somebody who can help them with the app or with some other part, or there might be some aspect of the connectivity problem that they're facing which we haven't solved yet. So I sort of feel that everybody needs to, where possible, help each other. So there's that list of what's delivered. Please jump in, guys. Again, I can keep going forever, but you might get sick of my voice.
Yeah, why don't we, before we hop over to that, why don't we get some intros here? So the agenda I suggested was based on the one we used for the Apache OpenRisk project, which is one we've done for a couple of years. It's the open source serverless framework, kind of similar to Amazon Lambda, but we run it as IBM Cloud Functions, and Red Hat's been in our community there. Yeah, so that's what it was based on, and they do similar to this. They've got like weekly town halls as well. And sorry, I got my dog here. Is that we have weekly town halls with them, and there's always a new set of community folks each week coming in, and there's always a different host each week that kind of volunteers to do it. But anyway, what's always great up front, especially I think now that we have the very first start to this, is to see if we can introduce everybody as a group, and just so we all kind of know each other. We know each other from Slack, but maybe I think, Andy, we can do that at least the first time here, and then in the future it's probably only the delta of new people.
Okay, well, so shall we go around then? Does anybody want to say hi? I don't know if you want to start, Ryan.
Yeah, sure. Hi everyone, I'm Ryan Kelly. I am a web developer, freelance web developer primarily. I teach in a boot camp here in Los Angeles at UCLA Extension. I'm a TA in it, and I had an interview yesterday to be an instructor. So I enjoy teaching and doing web development, and I really love this project. I think it's really cool. There's a lot of aspects that I'd love to get involved with it, but because web is mostly what I do, I have sort of focused on potentially building a web-based dashboard for some of the sensor accelerations, like Andy and I talked about earlier, but or at least to work as part of the team that does that. And yeah, that's me.
Great, thanks, Ryan. That's exciting. The dashboard I'm particularly excited about. Ludwig, do you want to say anything?
Yeah, sure. My name is Ludwig. I'm a geophysicist by training. I'm living in Switzerland. I graduated with a PhD on global seismic tomography from ETH Zurich in 2016, and have worked as a data engineer and software engineer at an IoT startup in the past 3 years, and also working as a software engineer at a larger shop. But I'm now gonna do a postdoc starting October, and it's gonna be on earthquake early warning, and one of my interests is application of low-cost sensors. So I thought there's a lot of overlap on what you guys are doing. So I just thought might make sense to get in touch and learn what you're doing, and so that's me.
Great, thanks, Ludwig. I feel like you could do almost everything we're doing on your own from that brief profile there.
Well, no, I guess not.
Where are you going to go for your postdoc, Ludwig?
That's also going to be ETH.
Okay, cool.
John Clinton, maybe.
Yeah, sure.
And we're all going to come and tour with you in Lake Zurich.
Yeah, we did an event there at ETH last year. John, were you there? I know Derek and Pooja were there.
No, unfortunately, I didn't go, though I visited Rusticon and IBM Zurich many times when I was part of the research team.
Nice.
Shall we jump now to Egidio? I've never said your name out loud before, but I've read it many times. How do I pronounce your name, please? I'm not sure if Egidio, you're on mute. I'm not sure if you wanted to say anything. Okay. Well, Egidio, and I'm sure I'm pronouncing it badly, has been wonderful in helping us with so many parts of the detection system. You'll see his name in the detection Docker a lot, so GitHub. So I'm very grateful. And we have Pedro, who works for IBM in Puerto Rico. Hi, Pedro.
Hi, everyone. I'm currently on the road in the University of Puerto Rico in Mayagüez in the Seismic network. So I'm meeting tomorrow with the director. So we're going to have a lot of great news soon. Happy to be here.
Great. Do you want to say anything about what you've been doing there with the sensors, the earthquakes in general?
Yeah, definitely. So current status, looking for the final locations where it's going to be. I opted for letting the seismic network decide where it is the best, like where are they interested in. So we currently have one sensor active at my house in Jauco, another one in Engine 4 in Bayamón. So we've already been receiving data. John Wallachy created an amazing dashboard where we can visualize each of the earthquakes. So now I guess next steps is thinking how we can improve a Grillo sensor with the context of Puerto Rico, since we have a lot of issues with energy. Every single week we have a blackout here where I live. So when that happens, the Grillos go offline. So we're trying to think of ways that we can make Grillo off the grid. So that's currently where we're headed in Puerto Rico. And then we'll be including the university students as well to help with the research process.
That's great. I wanted to say, Pedro, that I think we're all aligned on that goal for the sensors, because one of the challenges that we've had from the beginning has been connectivity, because earthquakes, maybe outside of California, that might be one of the few examples, happen in very rural areas, and even in California. And we often struggle with finding locations with reliable Wi-Fi or Ethernet. And so right now we're exploring with Arrow a new design which is based on a cellular modem. And one of the things that will happen, a consequence of this new avenue that we're exploring, is that we're going to have to do some edge computing on the device, because we can't be sending telemetry every second from a cellular modem. And so that's part of, I think, a little bit further down on the roadmap is, can we move some of this computing that we're doing off the detection systems in the cloud and onto the device? And that's like a whole topic there, a whole workshop. Many workshops we can do on that probably.
That's awesome. Really excited to hear more about this. I think that it's going to help people all around the world. So let's do it.
Great.
So, I've done just a little bit of edge computing with small MCUs, and the idea there is you can't do a lot from one, they're low power and that not very lot of CPU. But what you can do is you can sort of build that baseline, send enough data to the cloud, figure out what that baseline is, and then deploy just the model coefficients down to the edge so that you can do like edge filtering. And then your edge device is nothing more than, hey, I've learned the profile of what noise is for this particular location, and then things that are anomalous outside of the 2 standard deviations of what's normal, that becomes an interesting event. And that's when you want to turn on the cellular and start to stream more data. So there might be a technique there.
Right. I mean, could that Diego be, for example, or anybody else here, or Vaclav, Vaclav, I'm sorry, you've just joined. Could that be an STA LTA, for example, running on the device, and then when that triggers, we start sending data? Isn't that what MyShake did originally?
Yes, and I hope one day we move past STA LTA, but yes, I mean you can do that. The way MyShake worked is it had a simple ANN that was trained on all the offline data and then was deployed to all the cell phones to distinguish between somebody moving around, getting up and moving around, and an earthquake. So that is absolutely what you want to do, I think.
I just want to introduce Vaclav. Please, have I pronounced your name correctly?
Oh, Václav, yeah. Hello, sorry for joining late.
No worries. Can you introduce yourself and your project, which I think you actually talked about edge computing as well when we were talking.
Yeah, for sure. So to introduce myself, I'm Václav Kuna from originally from Czech Republic, where I'm right now, and I just got a PhD in Oregon State University, and I was thinking about trying the OpenEEW in Nepal. And I put together like a short proposal, and I'm trying to get funding for it right now. And yeah, I was about the detection algorithm. I was kind of thinking about, I mean, STL-ITA would be possible for sure, but I was also thinking about something like using polarization and stuff like that that will help us to distinguish earthquakes. And then maybe we don't even have to, if we are on like a bad coverage, just like a cell phone coverage, we might not even need to send data streams. Maybe we can just send some kind of very simple information about few properties of the record. Maybe we don't even need, because that will be probably something that we'll have to test when the sensors have the 2G, 3G module. But I guess in some locations it would be more efficient to send just a very little piece of information, and it doesn't need to be necessarily the data stream.
Right.
I guess it's more a guess than I haven't tested anything like that, but I suppose it would be possible.
The history, so everyone's aware, actually came from Gadlo a long time ago. Very early on in Grillo, Gadlo sort of pushed us to send all the data all the time, because I think he comes more from a big data background. So he was comfortable with a lot of data. We weren't so comfortable. But it's really paid off, because now we have this repository of earthquakes that we can use as a group here to run detection models on.
Yeah, I think that for when we have the connection, when we have solid connection, and when we can send all the data, I think it's good to do that for algorithm testing and stuff like that. But I think in some locations when the connection is weak and it would actually introduce a big latency in the real processing and stuff, and warning or the alert time would be longer. So I think that maybe in those locations we can go with something more lightweight.
Great. Well, now that we're all here, more or less, I wonder whether on the agenda we've talked about the new folks. I don't know if we need to go over what's been delivered. I don't know if Daniel or John or Luis wants to say anything about the different things that we've already got on the repos. Does anybody want to comment on this?
Okay, I can comment a little bit on the detection part. So in the GitHub repo, there are a lot of stuff. So allocated from different folders and different repos, differentiating between the sensor itself and the part that it's related to the firmware. And the part that actually Egidio here has been contributed a lot is in the detection part, in which it's the main algorithm that we have been using in the STA-LTA, and using this new exciting MQTT way of data that is helping us to transmit the data. So if you go to the GitHub, it's basically depending on what you want to do or what you want to contribute. You can find different sections, and that's part of what Grillo has released up to now.
And I would add there, Luis, that it's sort of I think that the Node-RED stuff is sort of complementary. I think they're two ways of doing the same thing, right? Like the Docker and the Node-RED are two ways of doing the same thing. That's the way I see it. The nice thing about Node-RED is you can visualize this flow of data which gets triggered, but the Docker has maybe a more professional sort of set of tools for somebody who's more robust set of tools. It has a data, for example, but they both can do more or less the same thing.
Exactly. In the Docker, it's and I want to thank here the people that contribute to that part, because it's basically when you want to work simulating basically the incoming data that Grillo has gathered during all these years. You can basically, well, we allocated in right now the main events. There are magnitude 7, 2 of them in Mexico. So what this section that Andy mentioned, it's very important, and it's great because allows us to simulate the incoming data in processing the data in real time and then working in an outcome. So up to this point, let's say the basic components of simulating the data and the algorithms that is basically detecting the earthquake is set there, and it's basically in a Docker, which is very efficient. So you can download it and then simulate this connection in your computer, or and work a little bit if you want using another algorithms and try new stuff.
Great.
Yeah, I think one of the great things about kind of the next phase with all the repos is letting things be simulated so people can build maybe on a specific component without having to deploy the whole system. So I think that's what's really good about that detection engine is you have like the test environment, but also if you wanted to deploy one of these, you have a nice little bridge out to, running it on a multi-node Kubernetes cluster instead of just the Docker engine as all in one. But in general, that's what I'd like to see myself. That's kind of one of my visions I hope happens is, people can come up with just the sensor, they can simulate a back end for it, where it sends the data, or they can simulate the detection engine, gathering information from one side and sending it out to a black box the other side. And then the same with the apps that are acting as the alerting tools. So in general, for new users to the project, that they can kind of pick one of the 3 paths they're interested in and just have some good simulation to start with. On either end of it, so that they can really be effective and test and be able to prove whatever their new change was or new enhancement works well.
Here's a question for John. I mean, the Node-RED flow that you did already, which we demonstrated, which pulls from the AWS Open Data bucket, feasibly that we could turn that into a real stream, couldn't we? Where we would grab one every second and send it and simulate these important earthquakes in real time.
That's right. So yesterday and the tutorial we wrote, my goal was to 3, because we were struggling to get the 3 in 1 hour. But there's lots more ideas that we could build. So one idea is go download a data set and play it back sort of in the real time. You've got it already chunked by second. We could just play that data into the system, whether you want to play it back as an MQTT feed or play it back into a dashboard and run it through your algorithms. That would be relatively straightforward. And so I want to put sort of what we taught behind me and let me now work with everyone in the community and experiment on what can we do. Can we scan a terabyte of data and find earthquakes, maybe that we missed, that you guys didn't even bother to highlight? Or can we really test some of the algorithms? I want to go work on those 2 things for sure. So sort of play back and then do a historical scan using the algorithm. I also want to work on a new Node-RED node that actually would implement the STA LTA. I think that would be a good project to encourage developers to work with me on. So that's maybe the third one. And the other, I had thought of one more project. You guys mentioned it and I've lost it now. So Dockerization, you can run Node-RED in a Docker container as well if we needed to. So we can certainly do a Docker Node-RED image. Did you receive one of these today, John, for testing? Oh, yes. So, yeah, so that's my other. So, yes, I just got this. So thank you. So my other project separate from Node-RED would be to go work with some of the firmware and start to take a look at the firmware side of this. Just first learn what you've done. Maybe do some videos of us together, especially if people start to get these and want to update them or contribute to the firmware. We could run a little video series on how to flash, understand the code and then flash new versions to your devices. Yeah. So yeah, thank you for this. This is going to be, well, I don't have no earthquakes in New Jersey, thankfully. Well, so we just had an update here. So for those that can see, it says imperceptible, so imperceptible, and it gives you the distance to the earthquake. So I think you got one of these as well, John. Now, now at some point I'm going to publish the code that we did for this on the GitHub as well. So we created a repo for alarms. But the reason we haven't been so oh no. Okay. Yeah, the reason we haven't been so forthcoming with that is because this needs a lot of tidying up, this firmware. It actually has some bugs that we're still working on. But the other reason is that we are sort of agnostic, or at least we have been. Of course, this community can drive us in a new direction, but we have been agnostic about how people get the alerts. Because in our experiences, and I've lived in many seismic places now, different areas have different requirements. In some areas, an IoT device is good. In some areas, a loudspeaker in the street is good. And in some areas, a radio broadcast is good. So we don't want to prescribe how people should be getting alerts. But what's useful about this particular device is it's a very bog standard IoT processor. In fact, it's got the same ESP32 as the sensor, and it's a really easy thing to program. So I think maybe, John, I might also put the code up and we can talk about how this device can become an example alarm device for OpenEEW. And people don't have to buy this one. I can describe the components that we've used here as well, because they're pretty easy on AliExpress to get. That'd be great. Yeah, so that's a lot of fun with hardware. I think we've got more people involved. We've got less people on the hardware side than we do on the software side. So I'm also thinking about doing a project page on Hackster and some other areas to try and get more guys involved there, because that would be a good place to develop things with. Okay, so in terms of what's been delivered, I think we've talked about this: the sensors, the detection, this sort of like multi-alerting options. What about
maybe the data, Andy? That is important. That is also it's available. No, we have. I mean, this has been running for more than a year now, but we have a database of basically a lot of information. It's basically sensors, two networks basically in Chile and Mexico that has been recording earthquakes since the end of 2017 in Mexico and from 2018 in Chile.
And also Puerto Rico since July, right?
Exactly. And from this summer, we have also Puerto Rico and Costa Rica. We have a sensor in Costa Rica. So all this data, it's available it's available for everyone. It's an open source as well. And as John mentioned, it's also very important to, for example, to take that data, and if someone wants to start testing machine learning on it, so in order to start differentiating between what is noise, what is an earthquake, the seismic catalog from the Mexican network is available as well. So we have the parameters of the magnitude, the distance to a different stations that we have, and this is available there. And a part of the data, it's what what you can find in the GitHub repo in detection, but the rest of the data is already there for everybody to try. For example, Ludwig, I don't know if you are interested in a specific part of an EEW. If it's data, it's there, or if it's detection, it's in the GitHub. I don't know.
Yeah, cool. Sounds interesting. So are these separate deployments? Like, are you running multiple backends for these different networks in different countries, or are you operating one Grilio network for the moment, which is based on the stuff that has been published in the repos, or how does that work right now?
Well, I think you've just opened up a very good discussion point, Ludwig. So there's a little bit of uncertainty how we're going to go forward. In the past, what we had done is we did have separate data centers. We've used everything: AWS, Azure. I think at the moment we're still on AWS for some things, but we always worried about latency. So in the case of Chile, the closest data center we could find was Brazil. And in the case of Mexico, the closest was East Virginia. I'm not sure, wherever we tried. So we did actually separate them into sort of different AWS clusters, different VMs and different landers, and et cetera, and different IoT brokers. But I think going forward, a discussion which I think would be really good to have here is how. What are we expecting, for example, the Docker to be? Because here's, I think, what we have so far. Anybody can start their own network. They can spin up a Docker, they can create a Node-RED flow, they can get the data, and they can output it to somewhere. But we also simultaneously want that data, if the user opts in, to also go into the central repository so that we can all learn from these different projects. We don't want them to just live and die in their own unique silos. So I think it's something that we have to weave in. We haven't given enough thought, because up until recently, this was a Grillo project, and we used to manage things in our own S3 buckets, and we used to do our own management there. But now that people will be hosting it on their own potentially, how can we also ask them to share what they're getting? Do we ask that their data gets buffered and then sent periodically to some OpenEEW repo? Or maybe we just take some of the key data. Do we want to know nothing more than where their sensors are located and earthquake events, not just the raw data? So it could be that, we have to think about this. I don't have the answers, to be honest.
But what Andy mentioned, it's very important, because, for example, basically what we did in between Mexico and Chile was to send all this data different repositories, and taking the data from there, applying the same algorithms. Obviously, we need to do the fine tunings in each one of them, but that allowed us also to validate the system to be in a scalable way. But at the same time, because the region is so different, we could check the differences, and then to estimate what will be more important, or different distances between the stations, or different trigger levels, and so on, to work with that data. So having a lot of data from different places, it's an interesting discussion. And as Andy mentioned, and I agree with him as well, it's having a lot of different networks in tectonic regions allowed us also to create more generalized algorithms that could maybe work in different places or similar tectonic places.
Right. Yeah. So I don't know if anyone has any more thoughts there, but that's definitely something we should keep discussing, how we can bridge between the individual projects and the greater global OpenEEW repository.
So how do you manage authentication between the sensors and the backend as of today? Like, how is there some kind of onboarding?
Good question. So I'm going to make a differentiation between how Grillo does it and how we've published it. So Grillo, up until very recently, and continues to, has a different version of the firmware that we published, where we are very much embedded with AWS. So we actually use the SPIFs memory. It's a sort of allocated memory on the microcontroller to store certificates for the MQTT broker. so no one can spoof a device or man in the middle. It's a secure connection between the two. Obviously, we didn't want it to be an AWS project, so what we did on the firmware that we cleaned up for this project is that we just made a sort of more generic MQTT client and publisher. And so in the instance of what we're having here, I think the one thing we added, I think Egidio helped us with this, was that you had to have a MQTT username and password. That was about the only security that we have at the moment. So someone could add certificates to this. We can add that. And so the process with OpenEEW you would have your device, you would add the firmware. The ones that we're going to be producing will have it flashed already, and then that device will instantly connect to the MQTT broker, which you program yourself on the firmware. And so that would be whatever IP address you want to give it, and then you will be hosting, be it on your local computer or on a server somewhere, your Docker or your Node-RED instance, and then whatever comes out of there, it's up to you. But ideally, somewhere inside of that detection system, it will also route data to a centralized location. The only other piece is how do you provision the device locally? So you might, up until now, I think maybe we should work on an app for this. We did create an app, which I think we haven't published, Luis, the one that we did for provisioning the device. It's a free Grio app, it's basically a clone of an ESP32 SDK. And in that app, it just allows you to pass over data to the microcontroller using Wi-Fi, the protocol called Smart Config. There's no reason why we couldn't embellish that and have it pass over other details, like your MQTT broker.
Yeah.
I also think we need to pass over latitude and longitude, maybe even from the phone itself. So I think I've added an issue for the latitude longitude. I should probably add an issue for the MQTT broker. But if we could do that, that would mean no one would have to get into C++ and Arduino, and some people may not want to.
Yeah.
So I got a question about more on the seismological side. Is there like a bigger plan to introduce more seismology algorithms in like detect location earthquake and estimation of magnitude, estimation of intensity, or I mean, I could probably help a little bit with this somewhere down the road, but I'm wondering if there is something like a road that you are going down and like when these things are going to be introduced, or whether you want to introduce them.
Yeah, that's a great question. Yes, the way that the repos are allocated and the code is there, it's basically allow to everybody to code, let's say, a new algorithm, and then to plug it inside the system in order for you to try new algorithms. No, so it's definitely you can go to the EEW detection, and then you can see right now we published the well-known STA-LTA. We're estimating also the intensity that we have been using, and this is something that Grillo came out as a unique EEW system, basically, that is detecting not only the shaking at the station, but also trying to estimate the shaking at distances. That's another problem, but that's also related to seismology. We have actually, from 2 years now, I think so, if I'm not mistaken, correct me, Andy, the simple algorithm to estimate magnitude as well. But in that moment, because of the lack of sensors that we have, and we didn't manage to tackle this problem very well, but there is...
Didn't we publish this, Luis?
I'm not sure. I don't think so. It's published yet, but
well,
it's something
that maybe Backlab and anyone else can have a look at this.
Exactly, because we did it. So we have the base to estimate the magnitude. We have the base to estimate the shaking, which is actually working in the simple algorithms. But definitely, if you want to come out with the new algorithms, we can work together, and then you can plug it inside. We can add it into the data that is already in the GitHub repo, or download the data from the S3 repository where we have it right now, and use the Docker to simulate the incoming of different stations that you want to try. Yeah, everything that matters is possible.
Could we potentially, I don't know what you guys think, have a different branch for different detection systems, and then just sort of in parallel see which one is more successful when we try it against the historic data? We can test different branches, because I'm aware that the system we have now is very crude. I think that was your point, right? And we could definitely improve it, but it'd be good to sort of have a sort of split test and see which one is better.
Yeah,
I think that's sorry.
No, go
ahead. Yeah, I think it's a good idea to kind of see whether traditional seismological techniques or machine learning algorithms will take us farther with the detection. And I think that's probably hard to say how it's going to go. And then, like, on the processing on the server side, I think that's another thing. Like, like determining magnitude and stuff like that. It's probably going to be more of a traditional seismology, I suppose. But yeah. But on the detection, I think that there might be something like, we may run several different branches of the same thing and see what algorithm performs the best.
Okay, we should definitely publish the one that we did, Luis, because we spent a long time on this. It just failed because we didn't have enough density. But just so you understand, what we did was, I think it had three steps. The first was to sort of locate the earthquake itself, triangulate it from the first 3 sensors that it hits, and constantly improve that as it hits more sensors, so that we're getting a more accurate location, and then work backwards from there to understand the magnitude. But we were never very accurate, and one of the suspicions is that our timing on the devices wasn't good enough because of NTP, and if the timing isn't right, you're going to miscalculate the distances. And so then we tried GPS, but there's an additional cost involved with GPS, and also it limits where you can install them. It can't be in a basement, for example. So I think there's a discussion there to be had. But if we could have if you could suggest one, and we can try a different branch, and we can test it, that would be great.
Yeah, definitely. And also, one of the good things is that right now we have, together with the data, the catalog of seismic events. So we know exactly what is the magnitude that we are trying to estimate using the simulation. For example, we can add up any new methods, no? And that will be it. And also to add it into the machine learning section, which is very exciting. We can also basically allocate and put classify basically based on magnitude and shaking level these events.
Yeah, I think that for the magnitude, the main problem is that for those very large events, for example, 6+, there is that saturation of the P waves, so we cannot really estimate the magnitude very well from it. And then also those big earthquakes also take quite a long time to actually happen. That magnitude 6.5 or so may take, 5-8 seconds. And then, like, what we actually record in the instruments, the first P waves that probably exceed the threshold that will trigger that STA LTA triggering algorithm, it's not going to be a true reflection of the magnitude of the event. So I think there's like more like things. It's like problematic from the seismological side, but I'm sure that like sorry.
The way that we thought about that problem before was that it was not, we didn't just give us a single output. That as the earthquake was developing, we were sending, we were updating our estimation of magnitude constantly. So, you want to say something as soon as you can say something, but you might get it wrong. And then in the next 10 seconds, you might update it, or the next 5 seconds with a new estimation. And so a client on their device might be saying, oh, it's going to be weak shaking where I am. But then in 5 seconds later, that might become strong shaking. And, I think that's better than, I think it's important to be in sync with the changing nature of the earthquake.
Oh yeah, absolutely. Yeah. I think that the warning should go out as soon as possible. Just the end user needs to be tolerant to kind of miscalculation of the expected shaking.
Yeah, and also I want to ask, I would like to add, sorry, that in that very moment, what we were trying to do is basically concentrate all the information into the cloud and processing the data there. But with this new approach of edge processing, we can do many things on the sensor side, and the sensor could be capable to do, you know, I don't know, I'm just gonna mention some, maybe an integration of the data itself in order to come out with the parameters that could be more trustful and take a decision there, and then send it only if those parameters are you know, enough to send the alert. So there are many things that can be done right now with this new release, especially in the edge processing from the edge processing point of view, more than allocate everything in the cloud. So that's something that we should try, definitely.
Just so as not to scare the non-seismologists here, Ryan, do you want to say anything about the dashboard?
Well, I was just getting started on using the Carbon design system, which is really cool, by the way. Thank you, IBM.
It's beautiful. I hadn't seen it before.
Yeah, it's really awesome. And it's got a lot of features in it that I think we'll find very useful. Not every design system has data visualization library incorporated into it, and whatnot. So I think that'll be very helpful. I did have a question though on it. So you were talking about authentication from the device side, but you know, when we're talking about a web-based app, we would also need, you know, authentication, or would like authentication, I think you said, in the application. And normally when you're dealing with just a private project, you know, you would throw up a database with a bunch of user information in it, which would be personal identifiable information and whatnot. And the company would then, it owns the application, would of course have control over that and be responsible for protecting it and whatnot. But what do we do with an open source project like this? Do we find other means of authenticating identity, or do we do that, but we just leave personal identifiable information out of it? Any thoughts on that?
Well, I would maybe think about Grafana and how they do it, because Grafana, which is an open source solution, they, from what I understand, they offer different options for authentication. So you can have none, which some people might prefer, if it's just you and your little network in wherever it is, or you can have the Google authentication system. I forgot the names of them, but there's a number of different systems that they can, or Cognito or whatever it is, and you can just the API for each of those services and use that one, or you can just have a password, a name and password, and leave it at that. So I don't hard code it into a configuration file. So I wonder whether we can leave that a bit open, that question. I don't know what your thoughts are on that.
Yeah, definitely. I think we can leave it open and research other ways. There's probably more novel ways of doing it too. I mean, you could potentially, you could use like blockchain or something like that for authentication, or obviously, like, it's a question you probably don't want to spend too much time on, because it's more fun to do the actual dashboard stuff. But yeah, it's an interesting.
I would suggest adding a registration for the people that we want to give access, at least with just the name and email. Don't be scared about, yes, it's personal identifiable information, but if just those two pieces of information, it's quite easy to handle, quite easy to encrypt, also keep it safe in services in the cloud. But at least you are aware of the usage of the dashboard, and that's going to be a very important key factor, because we will see the reaction of the people and how they use it, and we will like to know who is using it.
Yeah. Yeah, and I can imagine. No, go ahead, Andy.
No, go on, Ryan. Sorry. I
was just going to say, yeah, I mean, I would imagine if we get sort of the basics with it, if we had, if people did want to authenticate, they could start using, they could start having their own sort of user preferences for their own user interface and how they interact with the devices and the network and whatnot. That's what gives you sort of the advantage of creating a web-based UI, of course, is now you can deliver things that in a more easily accessible way, right? With a well-designed UI.
Great. And Ryan, do you just want to maybe help for the people who haven't been looking in our channel? with a dashboard? Just give them an overview of what the MVP looks like in terms of the functionalities.
Yeah, so it would be, just as far as the minimum product, I mean, it's going to be hopefully just what the raw accelerometer data looks like on the screen, and then also, being able to map geospatially where the sensors are. I think that's, Andy, what we had discussed initially, and that'd be a good starting point. Obviously, the potential for it could go a lot more than that, but it seems like that's a good start.
Yeah, that's amazing. So we use Grafana for that at the moment, and the problem with Grafana is it sort of does a lot of that already, but it doesn't have the feature to do other. It doesn't have the potential to do other things in the future, and there are some limitations about how people can use it if they want to use it for other purposes. So that's great. I think from our point of view, the first time we were able to visualize geospatially where our sensors were and their status, are they on or off, the way John did in Node-RED yesterday, like that for me was just a breaking point for us, because managing your sensors is everything. If you have in Nepal, for example, your sensor network and 20% are down, you can't guarantee a proper service to some regions. So I think that for me is fantastic, and being able to see the live traces is really, really amazing as well. I'm sort of tempted to share my screen here and just show you what we're doing already in Grafana. Oh, I can't, so I have to reboot the server. Okay. Anyway, so being able to see the live traces is really useful as well, and especially when you say installing a sensor, to see what the noise looks like as it's being installed is really helpful.
So would it be helpful? Well, there is a set of integrations with Slack. We could post the sensor up, sensor down status to a Slack channel, if you think that would be helpful.
Yeah.
Instead of, it's great to come and look at a dashboard, but I'm not always looking at the dashboard. We could have it post to a Slack channel, call it sensor status Slack channel.
So we did do that. We did do that before, John. I'll tell you what happened though, is that suddenly we were getting, because things go on and off a lot in the coast, so suddenly we were just getting like non-stop pings, and then you had to try and remember, wait, was that one off? Like, has that one just come off, or how long has it been off for? And it's hard to get a state of where they all are just by getting the constant updates of whether they're on and off, if you know what I mean. I think that was our, unless you had something else in mind, like a sort of graphic. Yeah.
No, the map is the graphic you want. So
right.
That's sort of what I built, just as a change the color, but it doesn't necessarily drive alerts.
Yeah.
Right. For the status alert, I think if you say like one of the stations it's not running and send the message, it could be definitely very annoying sometimes, because the internet sometimes just resets itself. But one of the solutions that we came out is to basically wait until a certain station it's been off for a period of time, let's say 15 minutes or 30 minutes, and then it's when you can send the alert. That could be one of the solutions.
The other question, John, as well is, at some point, the way I think I was imagining it, but please correct me if I'm out of sync here, was that people, a lot of this stuff will be no longer centralized. Like, people will have their own networks, and maybe we don't necessarily need to know what's happening in, network 6 in some region of New Zealand. Or maybe we should. I don't know. I'm not sure.
Yeah. So right now, the way I instrumented it, if the sensors hasn't reported in for 30 seconds, that's when you change the icon color. Now we could change 30 seconds to 15 minutes. That's just a variable. But what do you do with the information is what's really the conversation. Do we send it to a text? Do we post it in a Slack channel? Yes, you can change an icon on a screen someplace, but someone's got to be looking at that.
Yeah.
You could potentially, I mean, also, if we're talking about a web app, I mean, the same technology for you make the web app, like React, could easily make a native desktop application also, which has a little more accessibility towards notifications and whatnot than a web-based app. You use Electron or something like that to create a, native or, desktop app.
Oh yeah, having notifications on
That'd
web
be
app,
cool.
right? Or desktop app. Hey guys, we're running short on time. I just wanted to introduce Sasha, but now she's gone, so I'm not going to do that. Can't see her here. So yeah, just to sort of, I don't know if there's anything else you guys want to add, and anything at all. Anybody here?
No, I mean, just keep using the Slack workspace for what it is, right? That's so great. It's great to get everyone together and see everyone. This was awesome. But in between every other week, let's make sure we're communicating and collaborating in the Slack workspace.
Okay. Yeah.
And you guys are already doing a great job of that. So it's really good to see the community come together, and you're very welcoming. So I think we want to sustain that, right? We want to keep new people coming into the project. You want to welcome them and, find out what their interests are and, kind of engage them, give them interesting projects to help us with.
I think Luis, myself, I'm going to speak for everyone here, but Luis, myself, Carlo, and Diego were blown away by people joining. We don't come from an open source background. This is new territory for us. And the whole genesis of this felt very unsure. We were like, we've done this for a long time. We're very proud of this. It was a real step of uncertainty, but we're also aware of the limitations within our team to carry this out and to do other projects. So we are blown away that there are people alongside us now taking this project forward.
Yeah, it's a lot of people carrying shovels and water buckets. That's the way to do it.
Yeah, it's very exciting. No, I think you put it in a great spot when you had the GitHub repos prepared and getting ready to go. So I think we had a nice running start with it. So I'm very excited to see where it goes too.
Great. I think that's it. I mean, shall we say goodbye here? Unless anyone wants to add anything else, I think it's been a great first meeting, and I want to thank everyone for their time today.
Yeah, thanks a lot.
Thank you. Great meeting you guys.
Thanks, Andy.
Yeah, good to meet you.
Thank you. Bye.
Next one will be in 2 weeks. I'll post on the chat.
Great.
Great. Bye-bye.
Cheers.
See you.
Bye.